welcome to my follow-up video about packers. In the last video I explained to you how packers work and why you can't use tools like PID to check if a file is packed or not. There was still one question unanswered, which is why it might happen that, let's say you unpack a UPX packed file manually and you do not clean the dump, you put it into PID and it will still detect that this is UPX. Well, that does not mean that there is necessarily a second layer of a packed file. It is most likely just the case that PID still detects the unpacking step. If you do not remove the sections from the software envelope that unpacks the original file, then PID might still be able to find the strings that are typical for this. So basically you leave the code in there if you don't clean it. And that's what PID detects. Does not mean that the file is still packed. Alright. Now let's take a look at one packed file versus one unpacked file. And I will show you and tell you how you can spot the difference. And in this case, this is entirely about native applications, so it's always a little bit different if you have, for example, .NET files or let's say Visual Basic 6 files. Some things might be a bit different than what I'm telling you here. So, but let's take a look. UPX is a compressor, and it's pretty typical in terms of seeing how a typically packed file looks. So already if you look at the section, you will find section names that match the name of the packer, and you will also find some copyright notices that tell that this is UPX packed. But this only happens with common packers that are also used for good files. It does not happen with packers that are custom made. The UPX first, let's say the section UPX 0, it only exists in memory. You can see that the size on disk, which is called raw size, is 0, whereas the virtual size, the size of memory, is not 0. So this is where the compressed data will be put into an uncompressed. So it's one typical sign of a packer. The next thing is that this section that is executable, the last section, contains the entry point, and it's readable, writable, and executable. Those three together, they are also typical for packed files. Then the entropy is very high. 8 is the maximum value, so here is some compressed data in this section, definitely. The imports are not shown correctly with this tool, so I will use another one to show you the imports later. The strings, here aren't many strings that make any sense. Most of the strings are just garbage. What you still see in here are the imports. Those are the imports, the names of the imported libraries, and also the names of the functions. Those are the section names, the doorstep message, and some copyright notice. So that's it. There's nothing left from the file that is in there, that's packed in there, because it was compressed, and yeah, the info is just gone. Okay, let's check the imports. We'll be using Portex Analyzer, which is a tool that I created to parse PE files. And parsing PE files is a difficult task. You will often have cases like these, where one tool cannot read something and the other can. So if you see something like you saw in here with the imports, just use another tool and see if it is able to parse the file. So we will make a report of UPX packed, and we will make an image of the file, and it's UPX packed. Okay, let's see. I will also already put this into BE Studio because it takes a while for it to compute everything, and then make here the second one, the unpacked Radamant report and unpacked Radamant image, and create this. Okay. Okay, we find this is an unpacked malware sample. It was customly packed, and now we have here the unpacked sample, and there are many more strings. Most of the strings really make any sense. Look at this. I mean, it already tells you that it is Radamant. It has some kind of batch file embedded, and here's also the version 2.1. So some batch stuff, and here's the message of the ransom node. Now begins the decryption of your files. Oh no, it's not the ransom node, but some kind of message in between. So the run entry key for the registry, and that's probably the name of the batch file that will be dropped. So yeah, you can already see a lot of things just from looking at the strings. It claims to be from Microsoft. Of course, it's not. And the imports, there are many more imports, and this is really a more typical amount of imports for an unpacked file. So much more to look into. Okay, and is there something to look at here? Yeah, also the imports again. In the UPX file there were only 7 or so, and this is a lot more. So that's the UPX file, just for comparison. 7 imports, and they have these very typical imports for packers: load library, a get proc address. They are used to resolve the imports for the original file that they packed, so that the file can use its original imports. And that's why they are commonly used by packed files. You can also take a look into the anomalies section of POTX Analyzer. It will tell you some weird characteristics, like that in this case the entry point is in a writable section and in the last section, or that there are write and execute characteristics for those two sections. A physically overlapping section here. Also the name of the packer, that because based on the section name this is very typical for this packer, and it will also tell you that the size of raw data for UPX 0 is 0. So you find some things. You just need to know that these are actually typical for packers. And if you look at a lot of files, unpacked and packed files, you will soon see that certain characteristics are typical for packed files only. Yeah, it's always a bit of a rule of thumb. You will also find customly packed files with lots of imports. Malware packers tend to use, or some of them, they will create random imports, so it looks legitimate. And yeah, you will always see that this is more of a rule of thumb. This is interesting. You can here POTX Analyzer can create an image, a visualization of the file, and those are actually 3 images. The left is the byte plot. The byte plot is very useful to look for ASCII, for strings that you can actually read. So if I see this, I would look into this area for readable strings. Maybe they make any sense. And I would also look into this area, although these strings are the imports, as you can see here. The rightmost image is the PE structure, and it matches to this legend. And here you see the yellow rectangles, they are imports. And the green ones are the resources. So you can match this with these images on the left. And this is the unpacked sample, so this is a typical unpacked file, the look of an unpacked file. In the middle there are, this is the entropy, the local entropy. So some packers might slice up the packed part, and in this case the section entropy doesn't help. If the section has like one area that's not packed at all and one area that is, then the whole section as is, it will not have a high entropy. But you can still see that there are high entropy areas using the visualization. In this case, most of it is more in the middle, like 0.5, which is, as an example, typical for code. These black areas, they are very low in entropy, have lots of repetition. In this case, you can match this up here. It's containing zeros. So these are caves of the file, containing zeros only. Yeah. Okay, and then let's look at this. Looks very different, right? You can see that the byte plot, it does not seem to have much of a structure. It's like a uniform mess of all of the colors. And in the middle, the area is bright, except for some exceptions in here, but most of it is really, really bright. So lots of entropy there. So it's really compressed or encrypted. And you have to note that compression and encryption looks basically the same, because compression tries to remove repetition, and encryption does that too. If you are using a cryptographically secure encryption, it will look random, because they do not want you to see any patterns that may enable you to conclude what was encrypted in there. So a cryptographically secure encryption looks like compression, and that's why you also have a high entropy for these cases. For example, the XOR packed file that I unpacked with Python in the other video, you won't have a high entropy area for that, because this is XOR key that's very small, and there's still a pattern like repetition like area, and it will not be looking like this in this case. That's also why you have to take into account a lot of things before you decide if a file is packed or not. Yeah, you have to note that some packed files, they will put the original file into a string, and then you might have more luck looking at the byte plot and checking the strings with a tool like strings.exe, and seeing, then you will see if there's some large string that looks like base 64 or anything similar. So, well, I hope this helps you out. That's it for today, and thank you for watching. Please post any questions you have below. I will do my best to answer them either in the comments or in upcoming videos. So, yeah, have a nice evening.